Hi everyone, this is Jose Covarrubias and Thomas Evon. This is our presentation, and first we will hear from Thomas, and then he will pass the presentation to me. Here we go, Thomas.
Hi guys, welcome. Thank you for viewing our presentation. We're the masters of CIT 260, and we'll show you with this presentation. What have we learned so far this year? We've learned quite a few different things. We're going to start off with a couple of different basics. The first thing that we learned about was that we write Java for the programs for our text-based role-playing games. And in those games, we have these objects. And our objects can be persons, places, or things. So they're typically nouns. And a program must have at least one object, or it can have more, but at least has to have one in order to be a program. So typically, these objects are nouns, and they must represent something that's important. Within Java, we also have classes. We're not talking about school classes. We're talking about Java classes. The Java classes describe a group of objects of the same type. And they define attributes or important characteristics for each object. They define functions that objects can perform, and they start with uppercase letters and follow camel case format. We're going to go through a few different examples later of the different objects and classes for you as well. We also learned about attributes. Attributes are located within classes, and they describe data items that are associated with objects that are all of the same type. A variable is defined in that class for each attribute, and each attribute defined in the class must be logically related to one another. Within our Java program, we also have functions, and functions in a class define the behavior of the object, so it's what it does. A function is an executable block of code that performs some task. It's basically what you're telling the computer to do. Each function in the class must be logically related to one another. After our functions, we have instances, and it's kind of funny because Webster has an example, or they have their definition of an instance as an example or single occurrence of something, and that's exactly what it is in Java as well. It's an instance of a class. It's an actual occurrence of an object, and instances are the actual objects created from the class type definition. So it's what we get out of by running our functions. So we have different Java data types, and these are stored in different variables. They can be numbers, decimals, true false values. They contain a string or just different things. There's a few different things that we learned earlier in the year about bytes, short, int, integers, long, float, double, char, and boolean or true false values. These are all data types that we use in Java. So there's also types of values. Values are returned from Java, and they have certain types. You can also get strings, you can get decimals, whole numbers, true or false values, or sometimes you can get no output value. Void, public, static, integer, and boolean are just some to name a few. So with variables, we have instance variables and class variables. Instance variables are non-static variables, so the values are unique to each instance of a class. So example would be like the average speed of my car would be different from the average speed of your car if we were traveling to work. Class variables are static variables, so that means there's only one copy of the variable regardless of the number of instances. There's local variables. There's no keywords to designate it as local. It just depends on the location, and it's only visible where it's declared. It's only used within that bracket, that area, that local area. There's parameters, and these are variables, and they're typically found within parentheses. An example here would be the public static void main function, where you have a string of arguments, and the arguments would be your parameter. The arguments would typically go below this block or line of code here. Below this, there's also another example, and it's the double cubic feet, which equals the build control, which is calculates the volume of a prism, and the length, or the LHW, which would be length, height, and width, to calculate the volume of a prism there, would be the parameters. So we have also function signatures within Java, and this would be an example here of a public void attack, attacking a guy, attacking a guy who's also house attack. So we've got public, which is a modifier, void, which is a return type, attack, which is the function name, attacking guy and house attack are both the parameters, so that's the input values. So this is a program that my partner created. It's pretty cool. It's about, basically it calculates how many months we have until Christmas. And so the program starts here, and you can see in the comment section, it says this is going to be a test on Java classes and functions. The class is going to be Christmas. So that's our object, basically. We're trying to figure out how many days it is until Christmas. We start off with the main function here. It was the string of arguments. And so this here is a pass-by reference, since we're referencing what's given. And so this month is 5, and the year has 12 months in it. So we create an instance of the Christmas, and it pulls the parameters of this month and this year, which are basically double parameters, so they're number values. And then it goes into the algorithm here. It's the months of the year minus the current month from the parameters above, and calculates the double months to Christmas, which it returns and comes back and puts here. And then it prints out in so many months you will celebrate Christmas. And from here, I'm going to let Jose take it over.
Yes, so we're going to demonstrate how the function that my partner was talking about works. So let me just bring it here to the screen. Just 1 second, here and here. So I'm going to use two programs to demonstrate it. Here's the a text editor, text wrangler, and here's the here are the classes that we're talking about. So the main class is where all or any project will start with this statement right here. So any project that you do, whatever you have the main, that's where everything will start running on sequence. So we said that we have the variables already determined here, and this is obviously last month because we're in 6 months today. So these variables will be passed through here to the function that we are calling, which is to Christmas, and this other class. And so to Christmas, this class will execute the statement here on the function, which is deduct the current month from the total months of the year. Then it will return the value to the function, which eventually return the value up here, and will be print out. So I have that on my terminal, where you can run each individual classes. And I already run it. If you can see right here, it says in 7 months you can celebrate Christmas. But if I run it again, I have to do this, and then press enter, and it does the job. It prints out the statement I have here, plus the value that comes from the other function. So as we can see, this is something that we did a lot in our projects for the class, calling functions, passing variables, returning values, and printing the values to the console in this case. So by doing this, we learned that some classes can be used for different from other classes, and they can be reused. Because if I would have if I was to change any of these numbers, the function here will still give us correct answer, because it would do the same math over and over again. So even if I was to change it to 6 or 7 or 8, it would bring up the numbers. I can actually demonstrate it now. If I do 7, which is next month, and then let me save that, and then I go here, and I have to do something that we did at the beginning of the class, which is to reclassify the class, or to make it I can't even remember the name. To let me show you here actually better. So you do Java, and then you type C, and then you do Christmas again, and then type Java. So I will bring it up, and it's ready to run again. So Java, and then Christmas, and then here. So you can see here that it did the calculation again. So in 5 months you can celebrate Christmas. And as we can see, that it doesn't matter what the values we give here, our function that we're calling will always perform the desired calculation. So I'll pass the time again back to Thomas, and we'll go from there.
Alrighty, so we also learned about the development process on how to basically not only code a program, but the process of finding out the problem, getting a solution, and going through the process of delivering a good product to an end user and a client. We start off with defining the problem, and really you have to research, and you really have to think about the problem or the needs of what you're trying to accomplish. You have to think about the requirements of what you want the program to do. And you have to get an agreement from the requirements from either the client, your team members, the developer, whoever ultimately is in charge of the ideas. Then you want to gather some end user stories. So gather the major functional requirements of the program itself, and it basically documents the interaction from the end user and the system. This is really important because it basically gives a visual to everybody working with the program, the end user, the client, and the developer. It gives everyone an idea as to what's going on. It saves a lot of time. In designing a solution, we have modeling a high-level diagrams. We have class diagrams, activity diagrams, and we specifically did UML diagrams. Class diagrams is basically just documents objects and relationships between objects that need to be modeled. Activity diagrams describe steps of a business process that needs to be implemented in the program. UML diagrams define and document classes that and documents relationships between them. So basically, diagrams are important because it facilitates the communication between the client, end users, and developers, so feedback can be given early. Again, basically, it's for a foundation for a detailed design, development, and testing of the program. This saves a lot of time and headaches when you do it in the front end of a program. So you have a detailed design. You basically design a solution that requires a detailed design. You develop the sequence of the state package and deployment programs. The diagrams define, document, and describe the inner workings of a program. And it shows how the parts are packaged and deployed and used together. So it kind of gives you a visual of what's going on. So there's a prototype of the end user interface, and that's when in the design and solution phase. The prototype should be developed early in the high level diagram phase. It may include sketches or Photoshop of the end user story experience, again, to draw image, and it allows developers to get feedback. So that way, if they need to make any changes that the end user or the client just doesn't absolutely like, then they can get that beforehand. That way, before we get all these layers of code in, we can change that now. So the end user interface dictates the rest of the design of the program in essence. So we have to define functional test matrices, and a test matrix defines series of tests that must be performed. So they're passed to prove a program is working. Test cases, they specify inputs that are going to be entered and really what to expect as far as an output. Test cases describe the behavior of a program, so it ultimately makes it easier to understand. When you're developing and constructing the system, you construct it in different phases of the program. There's the end user interfaces, the database, and all the classes are all created here. Low-level unit tests are created and high-level function tests are created. When you're testing the system, you do a low-level unit test, high-level test cases run, errors are found, you report them. Certain ones are prioritized to see which ones are more important than others. If they're going to take a long time or not. Depends on how much time we have to work with to change them, etc. And then report them to either your team or the developers. We deploy a solution, so the code developed and tested is now deployed. So this is pretty much the final stages. You store the code in a repository library, kind of something like GitHub, and the code is shared with other developers. So later on, eventually it's installed on the system for testing, for input values, make sure everything's up and working, and then eventually it's installed onto the user system, which will be out and deployed. Just lastly here, just some miscellaneous notes here. It's important to get constant feedback from the clients, end users, and development team. If you take off on a project on your own, decide to do it on your own, the client, the developer, or their team members have different ideas to the approach, it may cause you a lot of headaches. So if there's key decisions or changes to a design, try to seek input from any key players on the team, any end user stories, investors. Just make sure that you ultimately listen and respond with constant communication. If not, then you'll travel several miles off course. So like Dieter Uchtdorf said, just a matter of a few degrees off from direction in the plane, and you'll be off course for hundreds of miles. So like programmers, we don't fly planes. Maybe some of us will be cool enough to program one someday, but ultimately we create programs. So a few degrees of communication off from direction can really put everyone at a loss. So there's 3 layers of a program. We have the model layer, the control layer, and the view layer. The model layer contains all the code that's responsible to store the data about all the objects. The control layer is responsible for all the logic that controls the game. So it contains objects that are responsible for getting and saving data, making decisions, and performing calculations. The view layer is responsible for input and output to the end user, so it's what they see. These objects create and display information for each end user story, and they receive input data entered by the user. That basically wraps up our presentation. I don't know if you have any questions, but if you do, you can email them to us. If you have any comments, feel free to let us know. This is our silly comment section here. End it off.
Yes, Thomas. I think one more thing. I would like to just demonstrate what we end up with our program so far. So
yeah.
If you let me, I'm just gonna bring the program here. All right, let me demonstrate a little bit what we end up doing. So hopefully everybody can see here. So from what my partner said about having the control layer, the view layer, the model layer, we've all been working on this, and just to run a quick demonstration and remind you again, the main class, it's always where everything begins. So in our main class, we started a couple weeks ago calling this the start program view. This function right here, this statement right here, calls it the start program view class. The start program view class starts to, begins to run the code that we typed in, displaying the message, the welcome message, getting the values from the user, storing those values on appropriate strings of code, and once those values are get, they are displayed on the console. When those values are obtained, then you start calling the other function, which was the main menu, and we call the main menu function. With those values, we start getting more input from the user to select options. As we learned this couple of weeks, the code start to run. We got our loops and our if statements and our switches. Once all that start to run, depending on those options, we call other functions. The help menu. So it's called from there, and then the help menu start to run again. It presents the options to the user, and then it starts to develop according to the option. One of the important things is the values, the life of scope of those values. It's good to identify where they stop, if they keep going or not. So a good example will be in the selection of the options. When an option is selected, in this case here, it goes through the options here, and according to the classes that we have or the functions that we have established, it would stop there, or it would keep running. In this case, whatever selection you choose, it will keep running on the next function that it's called. In this case, this one, it will eventually call for the help menu and the help to understand how to play the game or what the functions are. So a quick run here, just 1 second. Alright, so if I run our code, we get our welcome message, and I would test for invalid inputs or no inputs at all. So no input at all, enter, gives us an error message. And then if the input is short and gives the other error message, we're a little silly on these ones. So let's type my name, and then it gives me the welcome menu, as we said, the main menu. If I want to call the help menu, I'll type an H. So if I type an H, it brings the help menu. And then if I go from there to another option here, which is A, it will bring the other menu as well. And then any of those options, let's see, C, will bring the value or the message that we gave. And if I do D, it will bring the other display as well. And then if I just want to quit, I just quit, and it goes back, and it ends the program. So hopefully everybody is up to date, and this finished our presentation. Thank you for watching. Thomas, anything else?
That's it.
That's
Appreciate
it.
it, guys.
All right.